Next problem, how do we turn a velocity time graph to a force time graph? Well, we start with the in-between link, which is the acceleration. I always go from velocity to acceleration and then the force, or from the force to the acceleration and then the velocity. Right, so I try to have it ready. What do we have here? We have the velocity increasing for 10 seconds, staying constant, decreasing, speeding up the opposite way, slowing down. I need the slope, I need the acceleration, so I need to find the slope in all cases. So what is the slope here? The slope here is rise over run. So the acceleration here is rise, which is 10 meters per second, over run, which is 10 seconds. So I find that the acceleration is 1 meters per second squared. So the acceleration for the first 10 seconds is constant, and it's 1 meter per second squared. What is the force? Well, the force is mass times acceleration, and I remember that the mass was 2 kilograms. If the mass is 2 kilograms, that means that the force will be mass times acceleration, 2 kilograms times 1 meter per second. It will be 2 newtons. What about from 10 to 20? From 10 to 20, the slope is 0. That means that the acceleration is 0 meters per second squared. Well, the force is 0 newtons then. What about this? So this has the same slope. I can find from 20 to 30 the slope. It will be rise over run. It's actually fall over run. So it goes from 10 to negative 10. So the fall is negative 20. So it's negative 20 meters per second in 10 seconds. From 20 to 30, it's 10 seconds. So here the acceleration is negative 2 meters per second squared. So in this case, the acceleration will be negative 2. From 20 to 30, the acceleration is negative 2. That means that the force will be negative 4. From 20 to 30, the acceleration will be negative 4. The last part, 30 to 40, the acceleration is 1 again. It's positive. The rise is final minus initial velocity 0 minus 10. So we have a rise of 10 meters per second in 10 seconds. So it's 1 meters per second again. So from 30 to 40, I will have the same acceleration, 1. And of course, the same will happen with the force. The force will be 2 newtons. Now, what you can see is that I drew the lines. I didn't do anything in between. This is an ideal case. This is not a real case. So the correct way to do it is add a dotted line and not a real line, just so I show that I expected that it is connected in some way like this, but it's not real. I know it's ideal. And this, I will do exactly the same with the force. So I will add the values with dotted lines. That should be a dotted line, and this should be straight, and this should be a dotted line. Now, if you're going to do straight lines, that's fine. I'm showing you the correct way, right?